Jai Hind everyone. Today I am going to discuss the last unit of basic signal and system, that is the Z transform. So in the lecture I'll talk about the Z transform, the definition of Z transform and the region of conversion. What is region of convergence and what are the properties of region of convergence, and then I'll discuss some examples based upon Z transform including the region of convergence. So starting with the introduction. So this Z transform, it is one of the most important mathematical tool which is used for the solution of difference equations. As in Laplace transform, it is also a mathematical tool which can be used for the solution of differential equations. Similarly, this Z transform is used for the solution of difference equation, right? And just like Laplace transform is used for the continuous time signals, similarly the Z transform is used for the discrete time signals. Okay, that's why it is used for the solution of difference equations. So you can say that the Z transform can be considered as the discrete time equivalent of the Laplace transform, right? In Laplace transform we are using the operator S, right, and which is equals to sigma plus k j omega, right? And here in case of continuous time signal we are using the small brackets within that t, but for discrete time signals we'll use the square brackets either with the n or we can use nt. Okay, so the definition of Z transform for a discrete time signal can be xz will be equals to summation of from where n lies between minus infinity to infinity xn z ki power minus n, right? This is the definition for the bilateral or two-sided Z transform, right? For a single sided Z transform or for a causal system, the definition will be xz will be equals to summation from n is equals to 0 to infinity xn z ki power minus n. Okay, so in case of Z transform, mostly we have to just learn this formula and we can easily solve the questions based upon this formula. So now what is the region of convergence? That is ROC, right? So we can say that ROC is a set of points in the complex plane for which the Z transform, the complex variable called Z transform will converge. See, when a sequence is given, so the set of values for which the Z transform converges, that means the mod of xz will less than infinity is called the region of convergence, right? Or in mathematical form we can write that mod of xz will be equal, the definition, I'll put the definition of Z transform in this mode of, that is n is equals to minus infinity to infinity xn z ki power minus n. So when taking the summation outside and taking the modes differently, so this will be summation of n is equals to minus infinity to infinity summation mod of xn mod of z raised to the power minus infinity n must be less than infinity. Okay, so the ROC is actually the annual ring which is centered around the origin, right? So here this is the way in which we represent the ROC, and here the radius of ROC will be depending upon the question, that is in this case you can see r raised to the power minus n, that means this r is the radius in this case, right? So we can for two-sided sequence we can say that Z lies between, if the finite sequence we are having two different sequence which are of finite duration, then Z lies between r of minus x minus and r of x plus. This is the example. So in this case the small circle will be having the radius r of x minus and the larger circle will be having the radius r of x plus. So we can say that the ROC of r raised to the power r into e raised to the power j omega can be this. Okay, so what are the properties of Z transform? This is the important point to keep in mind, so that we can easily solve the numericals and we can easily find out the ROC of any question of any given value, right? So basically this ROC of the Z transform, it is a ring or a disk in the Z plane which is centered around the origin, right? And this ROC does not contain any poles within it. Okay, it does not contain any pole, right? It is a ring which is centered at the origin, and the ROC of LTI system is always containing a unit circle, right? So the region of convergence of Z transform must be connected region, right? So if we have right-sided sequence, right? So in that case, the ROC will be the outward from the outermost pole of XZ. That means the ROC, if xn is equals to 0 in a right side sequence, then ROC will be capital N must lies between n to infinity, or you can say the ROC will be the n, right? Or you can say, let's say R max. That means the ROC lie in this case for a right side sequence, the ROC lies between R max to infinity, or you can say it is the R max. For the left side sequence, the ROC will be the inward, right? That means in a right side sequence, the ROC will be the outside of the circle, and in case of left side sequence, the ROC extends inward from the innermost pole in the XZ, right? And the ROC in this case will be minus infinity to R minimum, right? Or you can say R minimum will be the ROC in this case, okay? And that means in this case, the ROC lies within the circle, okay? But if xn is a two-sided sequence, then ROC will be the ring in the Z plane that is bounded on the interior and exterior by a pole. That means if it is a two-sided sequence, then ROC will be either the inside or the either the outside of the circle or the inside of this circle, right? So we can say that ROC of the two-side sequence is of the form which lies between R1 to R2, right? So, but the condition is the sequence within infinite duration in the positive and negative direction must be there. That is, the two-sided sequence will be the sequence with infinite duration in the positive as well as in the negative direction, right? So, based upon this, let's solve some of the examples of the Z transform. So, in this question number 1, we have to find out the Z transform of the following sequence. So, before starting, first of all, we should write the formula of the Z transform, which is summation from n is equals to minus infinity to infinity, and this is xn and z ki power minus n, right? So, when putting the values of xn in this discrete form, I will get the value directly 2 into z ki power 0, right, minus 3 into z ki power minus 1. I have put here minus sign because we have minus 3 here, right, plus z into 7 into z ki power minus 2 plus 4 into z ki power minus 3, and here these are the 0, 0, that means coefficient is 0, that means the term is 0. So, this is the XZ, Z transform of xn in this case, right. So, if I am taking the z cube here as common, so this will be 2z cube minus 3z square plus 7z plus 4. So, in this case, this is the value of xz, and ROC will be the entire z plane except at z is equals to 0, because we have a pole at z is equals to 0. So, ROC in this case will be for this finite sequence, for this following sequence will be the entire z plane except the pole at 0, right, z is equals to 0. Now, another example, in this example we have to find out, I have taken 3 examples together, so that we can compare as well, right? So we have to find out the ROC of impulse function delta n and the shifted impulse function I have in the right side as well as in the left side. So ROC of the Z transform of the impulse function, and if I put the formula, the xz will be equals to summation of n is equals to minus infinity to infinity xn z ki power minus n. Since we know that impulse function is defined only at a particular point, so this this summation will not matter here, right? So I can define, see this is delta n given here, so I can write, so delta n will be, the value of delta n will be defined at only at z is equals to 0, n is equals to 0. So at n is equals to 0, when I have put here, this is delta n at n is equals to z ki power minus n at n is equals to 0 will be 1. Okay, so Z transform of impulse function will be 1. But if it is shifted by 1, impulse function is shifted by 1 in the right direction. So you can say in this case the xz will be equals to now here n is defined only at n is equals to 1 for n minus 1, right? So I can say delta n z ki power minus 1 will be defined only at n is equals to 1. So in this case the value of z raised to the power minus 1 can be written as 1 upon z. So this is the value of xz here. See, in this case when xz is equals to 1, in this case ROC will be the entire z plane, right? When it is shifted by 1 in the right direction, the xz is 1 by z, right? And the ROC will be the entire z plane except z is equals to 0, because we are having a pole at z is equals to 0. So entire z plane except z is equals to 0, right? Now if the function impulse function is shifted in the left in the left direction, right? In this case it is shifted to the right direction, and in this case it is shifted to the left direction by 1 scale. So here in this question number 3 we have the xz will be equals to, I can directly write in fact here that this value is defined only at n is equals to minus 1. Delta n here will be defined here only n is equals to minus 1. So the value will be z. So the value of xz here is z, right? Now there is a 0 at origin. So ROC will be the entire z plane except z is equals to infinity, okay, because there is a 0 at origin. We can say except z is equals to 0 or except origin, and I can say entire z plane except infinity. So are you getting my point? How we can determine the ROC and we can find out the value of the Z transform. Only we have to simply put the values in the formula and we can find the value of the Z transform, that is xz, and now ROC can be defined simply by looking towards the value of the xz. Now looking for the next example, in this case I am having the right-handed sequence, right, and the sequence is xn is equals to a raised to the power n un, right. So this is this un defines the right-sided sequence, that is from n is equals to infinity. So in the formula I will change the value of the summation from n is equals to minus infinity to infinity to n is equals to 0 towards the infinity, right. So xz for this will be summation of, and I am directly writing n is equals to 0 to infinity and a n z ki power minus n, Okay, when I am putting the value of n, in this case I am getting the a raised to the power 0 and z raised to the power, that means let's say this is 1 plus, and this is z की power -1 plus z की power -2. So first term तो will be 0, हाँ, something की power 0 will be equals to 1, है ना, plus a cube z की power -3 up to infinite. So we can see that it is the formula for the it becomes the formula for the infinite GP, right? And for the infinite GP the formula is, it becomes an infinite GP, and the formula for the infinite GP will be the first term upon the 1 minus the ratio or the difference of the two terms, two consecutive terms, right? So the first term here is 1, and then 1 minus the difference of the two consecutive term is a into z की power -1, az inverse. So this is the value of xz in this case, and now I have to find out the ROC. So for ROC, you can see here that az inverse must be less than 1. Okay, I can write az inverse, mod of az inverse actually must be less than 1. That means mod of a must be less than mod of z. That means z must be greater than a. So in this case, the ROC will be the outside of this circle, which is having a radius of a, and it is centered around the origin, and the ROC will be the outside of this circle. So this is the real part of z, and I can say this is the imaginary part of z. Okay, and this is the entire region outside the circle will be the ROC in this case. Okay. Now in this case we are again having the sequence, but it is not right sided, it is the left sided sequence. Okay, the question is wrong. We have to find out the ROC of this question. Okay, so now the xz will be equals to, I'll just simply put the value of my formula -infinity to infinity, and this is xn and xn z की power -n. So first I'll define this function xn. You can see here the value of xn will be minus alpha n or an, okay, or 0. For you can see here n is equals to -1 आएगा यहाँ से, right? So minus alpha n, it will be less than -1, or otherwise in this case the value will be 0. So the value you can see here, because of this u of -n -1, I can change the limit, yani that means -n -1, if I put it equals to 0, right, so it will become n less than equals to 0, sorry. So this will be because of u, okay, sorry, greater than equals to 0, then when I change the limit, then it will become less than 0. Okay, how I have derived this, I am just telling you. And this, in this case, now it becomes n less than equals to -1 will be equals to the value minus alpha n, and for the values for n greater than -1, the value will be 0. Okay, so now we can change our limit, we can change the limit from -infinity to infinity as summation from n lies from n is equals to from -infinity to -1 to -infinity. Okay, n is equals to -1 to -infinity, and the value is -an and z की power -n. So in this case, now to change this limit, let -n is equals to m. First of all, I am changing it to summation of n is equals to -1 to -infinity, or the values will be the values will be, let's say, minus sign I am taking it outside, and it is a into z ki power, let's say a raised to the power minus 1, z ki power 1, and it is minus n outside. Now let minus n will be equals to m. So I can change it to summation of m is equals to 1 to infinity. Okay, minus sign let be outside, and when I am putting the value of here, this will be a inverse z raised to the power m, and when I am opening the summation, let's say minus, leave it here minus sign, and this will be a inverse z plus a raised to the power minus 2 z ki power 2 plus a ki power minus 3 z ki power 3 up to so on. It is going till infinity. Okay. So for this, let me take, let me take minus sign outside. Okay, what is going on here? Minus sign outside, let minus sign outside, and it is again the formula for the infinite GP. So first term here will be a inverse z upon 1 minus a inverse z will be the value of the xz. Okay. Now to find out the ROC, I am converting it, also I can convert it, right, 1 upon, okay, a inverse z when I am taking common here, so here we will getting a into z inverse minus 1, minus of will be the xz, okay, xz will be 1 upon inverse z means az inverse. Now ROC for this case, I am changing the ROC will be, see, az inverse must be greater than 1 here, az inverse must be, mod of az inverse must be greater than 1, that means mod of a must be greater than mod of z, right. So in this case you can say that z is less than mod of a. So in this case the ROC will be the entire circle which is having a radius of a, inside of the circle will be the ROC in this case. This is the real part of z and this is the imaginary part of z. Okay. So you can see here, when we are having a sequence which is actually a left, it is a left side sequence, right. So for left side sequence I am getting the ROC which is inside the circle, and for right side sequence I am getting the ROC which is outside the circle, right. So what I have done here, I have I am not absorbing this minus sign. So in this case only what we have to look is that az inverse must be greater than 1. Okay. If I am absorbing this minus sign, right, you have to take care of this negative sign, because if I am absorbing it, then it will be converted to 1 must be greater than az inverse, and the entire sequence will change, and you will get in this case the ROC outside the circle. So don't look for this negative sign as it is given in the question, let it be this negative sign here only, and you can say that ROC will be the inside of the sequence. So what you have to keep in mind that for the left side sequence the ROC will be inside of the circle, and for the right side sequence ROC will be outside of the circle. So when you are doing, if you kept in this thing in your mind, then you will never absorb this sign, negative sign, and you will get the ROC inside the circle. Okay. So this is the difference between the two sequences. So if I am having the two sequence, for example, let's say if I am having one sequence alpha n u raised to the power n un, and another sequence, let's say beta n, and it is u of minus n minus 1. So in this case you can see the value of ROC for alpha n un. See, I am drawing two circles which are centered around the origin for these two terms, for these two sequence. Actually these are the two different sequences. This is sequence number 1 and this is the sequence number 2. So for this sequence which is having the alpha n un, so for this what I will be getting, z is greater than Z is less than alpha आएगा, or for this sequence which is a left side sequence, in that case you will get Z is less than beta आएगा. Okay, so you can see we can draw the two circle having, one is having the radius alpha, another one is having the radius beta, and you from here you can conclude that Z lies between alpha to beta, right? So from here I came to know that alpha is less than beta, right? And the ROC for this sequence, you can say that ROC for first sequence is outside the first circle, and ROC for the second term is inside the circle. So the ring in between, the area in between the two circles, this area in between the two circles will be the ROC for these two sequence. Okay, so once you solve these two sequence, you will get the ROC like this, and simply you can solve it with the formula. From here the summation will be from n is equals to 0 infinity alpha n z ki power minus n, and for this sequence the summation will be from n is equals to minus 1 to minus infinity, and this will be beta n and z ki power minus n. See, so for this case you have to put n is equals to minus n is equals to m. So for that, then you can get this sequence. You can easily solve the value of xz, which will be simplified value. You can easily use your maths, and then ROC will be the ring between the area between the two rings. Okay, so that's, I hope the lecture is clear to you. That's all for today's lecture. Thank you.